sorry. Hello, everybody. These notes are going to cover 4.3, which are proportionality theorems. So far in Unit 4, we've talked about similar figures. And whenever we talk about similar figures, remember that similarity comes with proportions. And so we talked about just similar figures in general, how to set up their proportions, how to find ratios. And then in our last video, we talked about different ways to prove that triangles are similar. And again, we are using proportions whenever we work with specifically side, 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 and side angle side. And then today we're going to be talking about different types of theorems that deal with proportionality, okay? With this first example of the triangle proportionality theorem, I'm going to show you what it is, and then I'm going to set this up maybe a little bit different than your teacher might. Just do what your teacher wants you to do. This video is just what I would teach my kids how to do. But you know yourself best, and you should trust your teacher and how they want to teach this to you, and just follow along with whatever they say. This is just another way to do it. Okay, so the triangle proportionality theorem states, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally, okay? So because I have this image here of a triangle that has two sides that are parallel, and that innermost side is intersecting both the right and the left side of the triangle, we know that all of our sides are now divided proportionally, okay? So the way that the proportionality theorem works is they're saying that A over B will equal C over D, which is kind of nice. All right, then we have A over E. So this small piece over this big piece will equal C over F. So notice that just whatever parts of the triangle I'm grabbing, they're going to be, proportional to the other corresponding parts. So we've got C over F. And then we've got B, so the little part, B over E will equal D over F. B over E will equal D over F. Now, that's a lot to remember with this triangle proportionality theorem. So when I teach my students this triangle proportionality theorem, I'm going to say the same thing that I did in the last set of notes, which is if you have a triangle within a triangle, redraw it, okay? So, and that's especially going to come in handy when we do something like this, where we don't have any information about the parallel sides. So keep that in mind, okay? So with this example here, what I'm going to do is I'm going to redraw this. And I'm so sorry if you hear my kids like crying in the background. They're fine. They're just mad. Okay, remember that when you have parallel sides, you end up with angle pairs, okay? So when I look at these triangles here, these two triangles share the tip part of the triangle, and then they have their two sets of corresponding angles, okay? So because of that, we know that these triangles are similar by angle, and therefore we can set up proportions to solve for whatever missing sides we are. So right now I'm looking at the top triangle, and every time I redraw these, I just draw these in the same order that they're given to me in. So this is going to be 33 and 27. But now I need to look at the full sides. So this big side over here will be 33 plus x. And then on the other side, I should know what this is off the top of my head, but I don't. I need a calculator. 27 plus 18 will get me 45. Okay? And now really what I'm doing is no different than what I did in the last set of notes. I am just grabbing those sides that correspond with each other, and I'm going to set up a proportion. And that's all I have to do, which is lovely. Everything over here is on top. Everything over here is on bottom. So I have 33 over 33 plus x, and that's going to equal 27 over 45. So I'm not going to solve this for you, only because we've done this now 1,000 times, and I don't want to have to do that for the sake of, the length of this video. So you know how to solve proportions, so you may solve those proportions however you would like to. All right, so the same thing's going to happen here. I've got this and this, this and this. They share the tip. So I'm going to redraw a small triangle. I'm going to redraw big triangle. My triangles are hideous. All right, so we've got small triangle. Ooh, we have a problem. If you look up here, I don't know what the top part of this triangle is, but good news for me, I was given the full side length and then this bottom part here. So to find that other side, you just do 14 minus 4 and you get 10. Yay. So now I know that this is 10 and this is x. I already know that this side over here is 14 because it tells me that. This over here will be 6 plus x. Again, we're going to set up our sides that correspond with each other. And then we would set up our proportion, keeping in mind this stuff goes on top, this stuff goes on bottom. So we would do 10 over 14 equals x over 6 plus x, cross multiply and solve. Okay. Again, all of these things are going to be very similar in how they work. I do really need us to focus on number 3 because number 3... Never mind. No, I don't need us to focus on number 3. Oh, I'm just kidding. Okay, so this triangle is not really any different than any of the ones we've done. It's just on its side. I don't suggest you try to redraw it so that like the tip is pointing up. I would suggest you leave it in its current orientation. My small triangle is a 12 and an x. My large triangle is 20, and then whatever 12 plus 4 is, which is 16. And then again, we already know what sides correspond with each other. Those two go together and these two go together. Everything up here will be on the top. Everything down here will be on the bottom. So I will do x over 20 equals 12 over 16, cross multiply, and you're good to go. Now, the triangle proportionality theorem would not work on this example over here whenever we are looking for the parallel sides, that x and that 20. So what I'm going to have to do instead is do what I was doing in the last set of notes anyways, which I would have my kids redraw their triangles. So because you're going to have to redraw your triangles sometimes, just do it every time. Just get in the habit of it. So this is my small triangle. This is 6 and x. This is my large triangle. This is 10 and 20. These sides correspond with each other. You've got 6 and 10. These two sides correspond with each other. You've got this on top, this on bottom. We have 6 over 10 equals x over 20. Cross multiply and solve. So even though we have this triangle proportionality theorem, I just have my kids redraw the triangles twice. It gets you in a good habit of doing that, and it ensures on problems like number 4 that we don't assume that 6 over 4 would equal x over 20 because it doesn't work like that, okay? So just, thoughts. All right, now we're going to move on to this thing called the triangle angle bisector theorem. And what this states is if a ray bisects an angle of a triangle, then it's going to divide the opposite sides into segments proportional to the other two sides of the triangle. So here in this picture, it tells us that ray BD bisects angle ADC, this big angle, okay? So really, I have this triangle. I have an angle bisector here, and so what's going to happen is it's going to cut my triangle into that angle at the top of my triangle into two congruent angles, and as long as those angles are congruent to each other, then you can set up proportions to solve for missing parts, okay? So it has a conclusion over here, and I don't really put anything in that conclusion. You can say that, nah, I'm not going to put any conclusion up there. Essentially, what's going to happen are these two sides are going to be proportional to these two sides. So like I could do a 1, a 2, a 3, and a 4, and we would say 1 over 2 would equal 3 over 4. It's not earth-shattering, okay? So I'm going to look at this example right here. I have a ray or a line, whatever, that bisects an angle in my triangle, and that angle is cut into two congruent angles. So I can use this triangle angle proportionality theorem. So I know that this 27 and this 18 are going to go together, and then I need x, and then I am missing this part down here. I know that the whole bottom portion of my triangle is 42, and I know that one part of that triangle is 18. So to find the other part, all I have to do is 42 minus 18, and I get that this missing part here is going to be 24. And now that I know that, I can just set up my proportion. X over 24 equals 27 over 18. Cross multiply, you're good to go. Okay? Okay, here we go. We have our triangle. Now, we're used to seeing our triangle not looking like this, but what we're doing when we do things like this is we're keeping like everything on one side of our triangle. That ratio is going to equal everything on the other side. So notice that this is kind of cut into a left side and a right side. This one's cut into a top and a bottom. We just want to keep the same parts together. Okay, I'm going to do this as 6x over 5x. And that's going to equal 10x minus 4 over 7x. Again, cross multiply. All of this stuff will be done in the completed notes. I just don't want to do it here because I want to keep the video kind of short. Now, number 7 is going to be a super, uber, duper important problem. This is the one that you're going to make the most mistakes on. You already are looking at this and saying, okay, I am missing this. I have that. We've already seen an example similar to this, except that where x is, I had a numerical value. So I knew that I just had to do my long side minus my short side, and that would give me my missing piece, my question mark. The process doesn't change. I'm going to have to put whatever the long side minus the given side is. Well, for us, that's going to be 15 minus x. Now, you're probably looking at this and saying, yeah, that's easy, Miss Olmsted. I don't understand what the problem is. The problem is that when you do this, people want to put x first. They want to do x minus 15. But when you do that, you're going to end up with saying the short side minus the long side. And if you have a short side minus the long side, you're going to get a negative number. And that's weird. Okay. So we have to pay very close attention to doing long minus short, not short minus long. But then again, this isn't going to change how I set up my proportion. This will be 15 minus x equals 15 minus x over 20 equals x over 10. And then we would cross multiply for that. My favorite. Parallel lines proportionality theorem. This says if 3 parallel lines intersect 2 transversals, then the segments intercepted on the transversals are proportional. Okay, so I call this the lovely train track proportionality because it looks like a train track. Is that the mathematical term for it? No. Do I care? No. So they told us here, it says given, A is parallel to B, which is parallel to C. So I have all these parallel lines. Now, I know normally we're like, parallel lines, give us angle pairs. Yeah, I don't care about angles right now, though, okay? So the way that this proportionality theorem works is these two things are going to be able to be set equal to those two things. So x over y equals w over z. Again, nothing earth-shattering. So here's my train track. When I set this up, I'm going to put those together and those together. 15 over 10 equals x over 14. Cross multiply and solve. Okay, now this one is a little bit funky. This one gives us these 3 measurements over here, and I have this. That's all I've got, okay? So when I look at this, it does give me information. It tells me that the length of AB is 50. So from here to here is 50. Since it's giving me a full side, I actually need to add up all of the sides over there, all those measurements over there, and get the value of the full side of the left side of this shape. So 8 plus 12 plus 10 is 30. Now, I'm looking for x, which means that I'm going to have to use this piece and the full piece, which means over here I will be using the same piece that corresponds with x and again the full piece. So I will set up my proportion as 8 over 30, and that's going to equal x over 50. You will cross multiply and you will solve. Now, none of this is crazy. The ones that you really need to watch out for are going to be this guy. And really none of these, but I would say if any of them, it would be this guy, because the normal triangle proportionality theorem doesn't apply to number 4. Number 4, you're going to have to split no matter what. But, you know, when in doubt, split them out and just split them and set them up, small triangle, big triangle. Okay, I'm going to finish this off, not on video, but the completed notes will be available to you. And if you have any questions over what we did today, just go see your teacher during their normally scheduled tutorial times, and I will see you in the next video. Adios, muchachos, goodbye.